Hello everyone, this is Unit 8, Solution and Acid-Base Chemistry. This is Section 3, pH Scale and Acid-Base Properties. You should be taking notes while you're watching this. Make sure that you highlight anything that you don't understand, make sure you ask questions, and be ready to go for the next class. So you've probably heard of the pH scale before. The pH scale is really a scale that is used to determine how acidic or how basic something is. Another term for how basic something is how alkaline it is. Alkaline. So alkaline is another term for basic. Think of alkaline earth metals. Alkaline earth metals, when they dissolve in water, make a basic solution. That's why they're called alkaline earth metals. So we go all the way to 0 to 14. Only exactly 7.0 is considered neutral. Everything less than 7 is acidic, and everything more than 7 is basic. And you can exist in that range to determine how acidic or how basic something is. So pH is measured by the hydronium ion concentration, or the H3O plus ion concentration. We know that the hydrogens come from acids because what happens is acids, by definition, release hydrogen ions, and these hydrogen ions will combine with water. So if I get H2O and then I throw in the H plus there, that's how we got the H3O. So the H plus and H3O we kind of use interchangeably, but typically I stick with the H3O plus rather than saying H plus, but they're kind of referring to the same thing. The hydrogen ion is released when acids dissolve in water. We're going to get into that a lot. Therefore, if you have more hydrogen ions or more hydronium, it means that you are more basic because you gave up more hydrogen ions, creating more hydronium. Now, if something is more basic, then it doesn't produce hydrogen ions. We'll talk about exactly what it does a little bit later on, but bases don't produce hydrogen ions. They actually produce something that uses or decreases the hydrogen ions. So they tend to decrease or lessen the hydronium ion concentration, and therefore you would end up with a high pH, being more basic. We say that the pH scale is a logarithmic scale, which means that for every increment on the pH scale, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, nope, just up to 14, every time you go up by 1, that is increasing the concentration by a factor of 10. So we are using a logarithmic scale here. Really, in terms of math, all you need to know is that it's based off of a power of 10, and that you need to know where the log button is on your calculator. That's about all we need to know about logs for this. So here's that pH scale. So we've got the acids all the way to the left. Notice this is color-coded as a rainbow. It's based off of something called a universal indicator, which we're going to use in our lab next class. And universal indicators tend to be red for acids and blue or purple for bases. So this is just a pH scale showing you some of the common household items or things that you're used to seeing, and showing you where they are on the pH scale and pH range. And this is kind of to show you that things that we use in our daily life can be considered highly acidic or highly basic. Okay, so here's what an indicator is. Indicators are pigments or dye. They're essentially a dye that shows different colors at different pH values. So if we use a universal indicator, which is what we're going to be using in our lab tomorrow, universal indicator indicates universally across all the pHs, ranging from red to purple, but most indicators don't do that. The other indicator that we're going to use in this unit is phenolphthalein, and phenolphthalein starts off clear, but then will turn colors once we get to basic pHs, and this color changes specifically at specific pHs, and this will give us an idea of when something changes from one pH to another. And we're going to talk about what indicators to use and why, but specifically, you want to pick one that changes colors in the pH range that you're using in your lab. But again, we're going to be using universal indicator and phenolphthalein most often in this class. Okay, something really important about acids and bases is that they tend to dissociate into their ions, meaning that they break up into their ions. Remember that these are ionic compounds. They are made up of ions. Therefore, when they dissolve in water, they're going to split up into their ions. So we'll start off with hydrochloric acid. Hydrochloric acid is made up of hydrogen and chlorine, so when it splits up into its ions, it's going to split up into a hydronium ion, or a hydrogen ion, and a chloride ion. Sodium hydroxide is going to split up into the sodium and hydroxide ions. We call this dissociation, and all acids and all bases do this. All of them will split up into their ions whenever they hit water. So these properties of acids and bases are things that you should start to study right away now, because these are things that people routinely miss on the test simply due to lack of studying. Now, I said that all acids and bases split up into their ions when they touch water. Therefore, all of them release ions in solution, because that's what it's saying. They split up when they hit water. And if we have ions in solution, we know that we have electricity. Remember, ionic compounds conduct electricity in solution because ions carry electricity. They react with one another and can form neutral solutions. This is what our lab is on tomorrow. They affect the pH of a solution and thus cause pH indicators to change colors. Again, that's what our lab is on. And highly acidic and highly basic solutions are very, very dangerous. A lot of people think that it's just acids, but bases can be just as dangerous, if not more sometimes. They both can be extremely dangerous to human health. We want to stay out of the extremes on the pH scale. Typically, the very, very low pH and the very, very high pH can cause us harm. And here's the last set for us, properties of acids and bases. Acids create solutions with a pH less than 7. They will react with metals to produce hydrogen gas. We'll do a couple of examples there. So that would be like HCl plus magnesium, and that would make H2 plus MgCl2. Okay, so every time we react a metal with an acid, it's going to make the hydrogen gas, and it's going to make some sort of a salt or some sort of ionic compound. Anytime we get carbonates, it's going to break down in a carbon dioxide gas. This is actually how the volcanoes were made back in the day. If you used vinegar and baking soda, it's actually this reaction here, acetic acid, which is vinegar, mixed with sodium bicarbonate, which is a carbonate, will produce that CO2. That's why they foam up so much. So I'm not going to do that reaction just because it's a little lengthy for me to write. But if we do HCl reacting with chalk, calcium carbonate, it would fizz up. It's going to form CaCl2. It's going to form, let me balance that. It's going to form H2O. And it's going to form CO2. So primarily the CO2 is what we are looking at here. So we know that acids release hydrogen ions, and when those hydrogen ions react with water, they make the hydronium ion, the H3O+. So acids are marked by an increase in hydronium ion concentration, which in turn translates to a low pH because pH is measured off of H3O+. Bases, on the other hand, create solutions with a pH greater than 7. We tend to think of bases in terms of cleaning solutions. They taste bitter, like if your mom made you wash your mouth out with soap, it tasted bitter because it's a base. It's slippery, also another characteristic of bases. And bases react to release hydroxides in water, or they cause water to release hydroxide. So let's say that I have OHs, and if I have, this is changing my perspective a little bit, if I have an OH and a random hydrogen ion floating around, they're going to bond together and they're going to make water. So they're going to make H2O. Now, if this hydrogen ion was left floating around, it would have interacted with water to make H3O+. So because bases create the hydroxide, they prevent this step from happening. They prevent the hydrogens from reacting with water to make the H3O+. That's why they absorb hydrogen ions. That would be actually why we say that hydronium ion concentration goes down when bases are produced. It's because the OHs steal a hydrogen to make more water, rather than that hydrogen going to be making H3O+. So at this point, you should know what an acid, what a base is, what their properties are. Make sure that you start studying this early, because this is very easy conceptually in terms of, like, you kind of have to memorize your way through what the properties are. But if you don't do it, you're going to miss a lot of points on the test, and I don't want you guys to miss points on something that really is just taking the time to study.